able to go to Music Fest, so we went so we could see the shows. But we'll see.
Oh, I'm going to Music Fest. I already get to say that.
It's all good. All right. Let's take a look at this bow work. We got 2 questions up here. A short one and a slightly longer one. Where we're asked, how many solutions does this equation have? What do we think? How many solutions does this equation have? Yeah, if I was to scooch things around, I could subtract the 1 from both sides and get that 3x equals 9. That one we can pretty easy spot. There's just going to be one solution for it. We don't have any exponents. We're not getting something that is forever real. We don't need to get exactly down to exactly the answer. You totally can if you want to. But this one only has one answer. That's all we need to do on the first one. The second one is what we were working with on Friday. We were asked to factor something like this. What do we do when we're asked to factor something like this? It's been several sleeps since we did it, so forget it. If I have 4 pieces, we're going to go, ew, I don't want to do 4 things all at the same time. So what are we going to do? I'd really not like to have to look at all 4 at the same time. What are we gonna do? We split them into 2 different groups. We're going to group them together with a plus in between so I don't have to deal with everything all at the same time. Splitting them apart. Because then I can look at each piece and say, what do these 2 pieces have in common? What do 2x cubed and minus 6x squared have in common? Two. Anything else? X squared. If I take a 2x squared out of that piece, 2x cubed divided by 2x squared, we're left with just an x. There we go. And then we have our minus 6x squared divided by 2x squared. We're going to have a 3. We do the same thing on the second piece. What does 1x and minus 3 have in common? What do they have in common? As a factor. What are factors of 1? What things multiply to make a 1? 1. And what things multiply to make 3? Only things that multiply to make 3 are 3 and 1. So the thing we said in both lists was a 1. So they have a 1 in common. And that's going to have us leave a leftover of 1x minus 3. That's what we're looking for. We're looking for these 2 pieces to be exactly the same thing. So we take them out as their own little GCF. So this guy's going to go in front where we have our x minus 3. And our leftover bits go together with my 2x squared and that plus 1. Questions on that bit? Because we're going to use that a bunch today. Okay. No questions on this one? All right, this is week 5. Please make sure you put that at the top of your bullet page. And then I'm going to put up the little SAT practice question, and then we'll get into our notes for today. And this actually ties into what we're doing a little bit today as well. So if we give you an equation that looks like this, the function f is defined above. Ta-da, we gave you a thing. Which of the following is not an x-intercept of the graph? So how do we find the x-intercepts when we're given something that looks like this? Yeah. set each of the chunks equal to 0. That gives us our x-intercepts, our roots, our zeros, our solutions, those guys. So if I set this one equal to 0, the x plus 4, what would we get? What would our root be? -4. So we know that that guy is one of our roots. So we know that one is. How about x minus 1? What's our root there? Yeah, it's a positive one. So if we set that equal to 0, we know we've got this one here. Then we got this one. That one's going to take a couple of steps. So we're going to actually write this one out. So if we take that 2x minus 3 and set it equal to 0, what do I do to solve for x? Add 3. So we're going to have our 2x equals 3. And then getting our x by itself. What do I do to get my x by itself here? Divide by 2. So we're going to have 3 over 2. So that tells me that this one is my other one that's real. This one was the green one. So the one that answers the question, the which one is not one of our roots, it would be B. So we had to find all of our roots, solution zeros, x-intercepts, in order to figure out which one it wasn't. But even if we forgot what to do on this guy, or we didn't want to, it only got us down to 50-50. So even if we just get rid of some of the answers that we know it's not going to be, it's better than just a blind guess 1 and 4. Questions on this one? So this is like a factored form looking thing of a polynomial that we just found some roots and solutions for when we're given a factored form of a polynomial. Wonder what we can do if I give us a not factored form. What we're going to do today, we are going to do some solving. We're going to find those roots, solutions, zeros, x-intercepts, just like we did in that practice SAT question. But I'm not giving you a factored form, I'm giving you a standard form. We're going to do the whole thing.
Can't you times 4 and 25 to make 100?
You're not wrong, but does that help us with this one?
No.
I was going to say,
Just automatically win.
that's fine, absolutely fine to find some patterns and things. Totally fine. I'm like, you're not wrong. You really are not wrong. It doesn't particularly help you in this case, but you're not wrong. So this is going to be the first one we work with. I'm giving you a whole standard form polynomial, and the instructions say solve. When the instructions say solve, what that means is we need you to get all the way down to a solution, a root, a zero, an x-intercept. Your answer should be either an x equals blank, or you put it as an ordered pair, which will always have a 0. Because it's going to be a 0 or a root or an x-intercept. Bless you. So when it says solve, you are getting down to either an ordered pair or an x equals. And I don't care how you write it, but it needs to be written as one of those. So we look at this whole guy over here, and we say, well, ew, there's 4 pieces. Ew. What can we do when we have 4 pieces and we are asked to solve by factoring? What do we do with something like this? More specific. We separate them into the groups, just like we did in the one in the bell work. We're going to split this up into pairs. So I'm going to split this up, and I like to remember we have a plus in between. So I'm going to put these two together. My x cubed plus 4x squared. And then I'm going to add negative 25x minus 100. I highly, highly recommend doing it like this. It will save you tears and heartbreak on signs if you write it like this. Every time with a plus in between here. And if there's a minus sign right here, you just tuck it in over here. Just boop. Otherwise, you're going to wind up with signs that don't match up right. So then we're going to look at each of these pieces. What does this purple piece have in common? My x cubed and my 4x squared.
X squared.
And x squared. So I can take this and write this as x squared. And my leftover piece, we're going to have an x plus 4, right? What do minus 25x and minus 100 have in common?
Negative 25.
Negative 25. So we're going to take a negative 25 out. And it's going to leave us with x is negative 25x divided by negative 25.
Plus 4.
And negative 100 divided by negative 25 is a positive 4. So to get this into our factored version of this, where we finish this job, that's when we take our piece that matches up exactly, this x plus 4, and we're going to put those together. Pull that out like its own GCF. That's what that is. And then the leftover bits go together. My x squared and plus negative 25 minus 25, right? And this thing still equals 0. Well, I definitely have enough information here to get a factor, a root, or a solution. Is there any more factoring we can do? We've got a difference of perfect squares. This guy right here, x squared is a perfect square, minus 25 is a perfect square. This is a difference of squares. So you can either x and box that thing. You can remember our special pattern. But we're going to wind up with a factored form here with my x plus 4. What's up? Oh, okay, cool. Just making sure. It's like I just could hear that there was talking. I just couldn't tell what was being said. So, yeah, no, totally fine. I totally get this sometimes needing to talk it. Shock, right? So we can put this through our difference of squares pattern where we have what was squared at the front. So that's my x. What was squared at the back? What squared gives us 25? 5. What happens with my signs for difference of squares? One's positive, one's negative. So what are our solutions?
Negative 5 and positive.
Yeah. So just like we did for the one in the SAT practice, I'm going to take each of these things and set it equal to 0. And if you need to write that out, that's totally fine. My x plus 4 equals 0. We're going to get that x equals negative 4. On my yellow ones, we're going to wind up with the same kind of vibe. X plus 5 equals 0 means we're going to get x equals negative 5. And for my x minus 5, we're going to get a positive 5. So this is all our solutions, roots, zeros, x-intercepts for this guy up here. And writing them just like that is totally fine, 100% answer. Questions on this one? Because we're going to practice this a couple more times. Okay. Here's our next one, solving by factoring. We've got an x cubed plus 8x squared minus 4x minus 32 equals 0.
I think just putting what together. The last number or something.
You are noticing patterns in here. I love it so very much. I love it. Because we're being nice. That pattern shows up whenever we do something very particular in the midst of the factors. Okay, so looking at this one, we've got our x cubed plus 8x squared minus 4x minus 32 equals 0. And just like we did on the last one, we're going to factor this one by our grouping. So I'm going to put these two pieces together, and I'm going to put these two pieces together. So we're going to have our x cubed plus 8x squared. Fixing that parentheses is too dang low. And then we're going to add our negative 4x minus 32. Breaking them up into pairs and putting a plus in between. You always want to have a plus there, I promise you do. All right, what do these first pair have in common? My x cubed and my 8x squared. What do these have in common? An x squared. So I can write this as my x squared times that leftover piece of x plus 8, right? If I redistribute that, we get exactly where we were. How about for my green piece here, my minus 4x and minus 32? What do they have in common? A negative 4. So I can write this as negative 4 times that leftover piece of x, because negative 4x divided by negative 4 is just x, and negative 32 divided by negative 4, negative 4, is a positive 8. Norse mythology aside. It's early. My brain is not brain well. Okay. So now that I have that same piece in my factor, I'm taking this guy out as its own greatest common factor. This is my GCF of our polynomial. So we're going to put this as our x plus 8. And our leftover, friends, after we take out our greatest common factor of x plus 8, we're left with our x squared plus negative 4, or x squared minus 4. Does everyone see where those pieces come from when we're factoring? That's probably the trickiest part to spot in these, is the factoring part. And now what do we have? A difference of squares again? What? Oh my gosh, that, and Abigail, you will spot that pattern every time there's a difference of squares in the factors that are left over. So sometimes it'll be slightly more convoluted, but especially if there's no a value, what you're noticing there is the result of having difference of squares being a factor. So if I write this in our full out factored form, because that is a difference of squares, we're going to have our x plus 8. And if you do not know that pattern for difference of squares, you can absolutely do this piece still with the x in the box. Where we have our a times c being negative 4, and it's going to add to b the b. There are no x's, so there are 0 x's. That's where we're going to have that positive 2, negative 2. So they multiply to be negative 4, add to be 0. And if you put those through the box, that's when we get our x plus 2, x minus 0, minus 2 equals 0. So you can absolutely still x and box it. And if we didn't get a difference of squares, that's how we would find that next piece. So what are our roots here, our solutions?
Negative 8, negative 2.
Yeah. Again, we said each of these pieces equal to 0. X plus 8 equals 0 means we're going to get that x must be negative 8. Or we could write this as the point negative 8, 0, just so we see it both ways. This one gives us that x equals negative 2, which again would be the point negative 2, 0. And our x equals positive 2, or the point 2, 0. They're always set up to equal this 0 over here. That's what that's telling us. Okay. Questions on this one? I'm going to do one more. Slightly harder, but the same vibe. Okay. Last one for today. This one's slightly harder. Got 4x cubed plus 12x squared minus 9x minus 27 equals 0. So again, we're going to split these up so that we can put them into our groups, because I don't want to deal with 4 things at once because that's too many things. I'm not good at juggling, let alone with 4. Ew. So I'm going to put the first 2 pieces together, and I'm going to put the second 2 pieces together. So we're going to write this as our 4x cubed plus 12x squared. And then we're going to add our minus 9x minus 27. And that equals 0. That way we can look at each piece individually. So looking at the purple piece in this case, my 4x cubed and my 12x squared, what do they have in common? Just our purple group, this first group.
4x squared.
Got a 4x squared. And that's going to leave us with 4x cubed divided by 4x squared. Leaves me with just an x. And 12x squared divided by 4x squared gives me a 3, right? How about my minus 9x and minus 27? What do they have in common? -9. And that's going to leave over with the leftover pieces. -9x divided by -9 gives me just an x. And -27 divided by -9 is a positive 3. Y'all, I said we're on the last question, not that we're done, so the music should not be playing right now. I can hear music all the way up here, which means your music is too loud. So we know we've got our matching pieces. So this guy matches this guy, which means we're taking this out as its own GCF. That's what we're doing here. Those merge together and become our x plus 3 out in front. Our leftover bits, that's when we have that 4x squared minus 9. What can we do next? Yeah, we've got to factor out the second thing. This guy's icky. They're both perfect squares. So if you notice that difference of squares pattern, absolutely, we can totally use that. If you don't notice it, you can put it through the x in the box. What squared gives us the 4x squared? This is a 2x minus the 3. So that's going to help us build our pattern. So we have our x plus 3 that's out in front. And then when we come to fill in our difference of squares over here, our factors are going to be what? What are we going to put in these blanks here? Not x plus 2.
2x.
We need to take the thing in the front. Our 2x goes in the front. What goes in the back? What goes over here?
3.
The 3. So it's using this piece, the thing that squares to make the 4x, and what squares to make the 9. So it's going to have the 2x and the 3. One gets a plus, one gets a minus. You can also do that in the box. If that is not a pattern that you are super comfortable with, do it over here. Our A times C are 4 times -9. That's going to give us that -36. And there's no middle value. There's no B, so we have a 0 at the bottom. Our pair of number that would multiply to make -36 and add to make 0 would be a 6 and a -6. And if you put this through a box where we have our 4x squared and our -9, and you put your -6x and your +6x, you can absolutely do it this way. It's totally fine. It's going to give you those exact same factors. Our 2x and a -3 with a 2x and a +3. So you can do it either way. If you know the pattern, it's going to save you some time though. So then we need to get to our root solution zeros. So this one's not bad. Our x plus 3 is going to give us a solution where x equals -3. For these guys, we are going to need to work it out a little bit. So we're going to need to take our 2x plus 3 and equals 0. What do we do to figure out what x is going to be? Subtract 3. So we're going to have that 2x equals -3. So what does x equal? -3/2. -3/2, -1.5. And I do not care if you write it as decimals or fractions. They mean the exact same thing. We do the same thing for this one. So whenever you have a number in front of your x, you're really going to have to work it out. It takes a lot of practice to be able to do that in your head. 2x minus 3 equals 0. It's the same kind of process. We're going to add 3 to both sides this time. So we're going to get our 2x equals a +3, which means our other root is an x equals +3/2. So these are our 1, 2, 3 roots. Okay? Questions on that one? That's everything on homework 5-2. We're also going to do a skills check tomorrow. So that's like one of the ones where I grade every single question. There's a couple of like multiple choice questions on it. But homework 5-1 and 5-2 are basically your study guides for it. So we're going to do that tomorrow. And then we'll get into the last 2 sections. I'm going to pass back all the homeworks that I have for you guys right now. But if you got questions on stuff while I'm walking around, please feel free to stop me and ask questions and all that jazz. But yeah, it's kind of the vibe. You can actually get time to work and ask questions. And what? If you need a copy of homework 5-2, it's still the one standing up in the third pocket down on the hingy thingy.